Hi everyone, welcome to today's video, which is a quick look on the chapter of ray model of light. So let's draw on to the first concept that we are concerned about. In this chapter, the first thing that you come across is the idea of luminous as well as non-luminous objects. Now, luminous object refers to objects that can give off light by itself, such as your fire, the sun, or firefly, etc. Non-luminous objects will refer to objects that are unable to produce light, such as objects like your apples, your pencil case, the moon, the tables, etc. Alright, so there's these two different types of objects that you might come across in your daily life, and let's take a look at how it allows us to see them in different ways. Now, for luminous objects, because they are able to give out light, right? So the light rays can actually reach our eyes, and by doing so, it allows us to see the object. So for the flame or for the sun, it's the same way, right? So if the sun and the flame's light ray reaches our eyes, we are able to see the object. Now, for objects that are non-luminous, like the apple, the moon, how do we see them? For these objects, they must be able to reflect off light, such that the reflected light rays reaches our eyes, and that actually allows us to see the object and the respective colors. So same for the moon. When the light rays are reflected, that's when we are able to see for ourselves how the object will look like and the color that it exhibits. So do take note that that is how the human eyes perceive objects as well as perceive colors. The second concept that you come across in this chapter is on the properties of light. Now, the properties of light can be categorized into three different types. First and foremost, light is the fastest possible thing that you will come across in your science syllabus, right? It's traveling at a speed of 300,000 kilometers per second. And do take note that it might change depending on the material that light passes through. So light can be slightly faster in certain material and slightly slower in certain material. Okay, but overall, the speed of light is still within about 300,000 km per second. So even if the speed changes, it will not be that drastic. The second property of light is that it travels in a straight line. Now, why is this interesting? This is because we need to remember that light always travels in a straight line and is unable to bend or to be able to twist itself around corners. And this is the reason why when looking at a wall, right, you can't see the object that's behind the wall because light from the back of the wall cannot twist itself to come towards your eyes. So in this example, we have a torchlight over here, right? So if the torchlight shines the light ray into this tube, right, the light ray traveling in a straight line will hit this corner over here, right, and it will not be able to reach out to the eye, and as a result, the eye will not be able to see the light ray that's coming out from the torchlight. Right? So we must always remember that light travels in a straight line. However, it is possible to change the direction of light, for instance, by adding, say, a piece of mirror over here, and that will cause the light ray to be reflected. Then adding another piece of mirror over here will cause the light ray to be reflected towards our eyes, right? And that is something that we'll talk about it later on. And last but not least, light is a type of energy. Next, in this chapter, we also talk about this concept about the modeling, which is the ray model of light. Now, we need to take note that when we are representing light, because we can't see it in real life, but in order to show how it functions and what can we do to change it, when we do it and represent it out, we need to use a model. So how do we represent them? Since light travels in a straight line and it has a direction, light rays are represented by a single straight line with an arrow, while light beams, beams meaning that it's multiple rays, will be multiple light rays traveling in straight lines parallel to one another. They do take note that it should be parallel to one another, and it should be pointing at the same direction. Okay, so that's how you represent them in the ray model. So using that concept of ray model, we can explain a lot of phenomena around us. For instance, shadows. Now, if light travels in a straight line, as shown in this example 1, once it hits an object, let's say this human being over here, okay, because light is unable to twist itself around this object or to pass through this object, because this object is opaque, right? Because like you and I, we are humans and we are opaque, and the light rays will stop once it reaches this particular object. As a result, light does not go beyond this object, and this casts a shadow behind the object. And that's what happens when you walk under the sun and you see your shadows moving, so and so on. Going further, thinking about what happens with shadows, or rather the blocking of sunlight, can affect natural phenomena around you, such as eclipses. Now over here I have the sun, the moon, as well as the earth. We all know that they are always in constant revolution around one another, right? The moon is revolving around the earth, and the earth is revolving around the sun. So there might come a point in time whereby either of these objects, either of the moon or the earth might be in between this entire line, which means that it could be that it's the sun followed by the moon followed by earth, or it could be the sun followed by earth followed by the moon, right? So depending on which is the object, it can actually result in what we term as solar eclipse as well as lunar eclipse. Now I hope you still remember what they are. If you're not sure, you can refer to your notes or discuss with your friends. The other concept that we spoke about in this chapter is about the reflection of light. Now, if you recall, when light hits a surface, right, it will definitely get reflected off. Now, however, that does not mean that every single surface will give you a very nice mirror image, right? Because it depends on the type of surface. So in this part of the concept, what we learn is that when light strikes a surface, right? So let's say that this surface is represented by this white color box over here, right? So when light ray hits, that's what we call the incident ray, which is the initial light ray. When it hits it, we can actually calculate something that we call the angle of incidence, which is represented over here, by having an imaginary line called the normal, which spans across the surface at a 90-degree angle. Okay, so the normal is always 90 degrees to the surface. From there, we can measure this angle, which is called the angle of incidence. And according to the law of reflection, we know for sure that the reflected light ray will have an angle of reflection that's exactly the same as the angle of reflection. As the angle of incidence. And the light ray that comes out is called the reflected ray. Okay? Do take note that the light rays are always drawn with a straight line. So please use a ruler to represent it, and there must be an arrow to show its direction. So, in the law of reflection, we learn that the angle of incidence must be equivalent to the angle of reflection, regardless of the type of surface. Like what I mentioned just now, it doesn't mean that every surface will give us a nice reflection, because ultimately it depends on what exactly is the surface. For instance, if the surface is a very smooth surface, right, such as a mirror, okay, what happens is that every single light ray that hits the mirror, right, will be reflected off according to the same angle that the other light rays are at. So for instance, because the surface is smooth, right, all the normal that's being represented over here will result in the same type of angle of incidence for each of these light rays. And when that happens, we can expect the angle of reflection to be the same for all reflected light rays. As a result, whichever object that appears over here will appear the same as we see over here. And that is actually how the mirror works. Right? When you look at the mirror, that's the reason why you will see a clear reflection of yourself. So this is what we call regular reflection. The image is very clear and it's undistorted. That means you don't get elongated, or you don't become wider from left to right. So every ray is reflected by the same angle in a smooth surface in a regular reflection. On the other hand, sometimes if the surface is too rough, for instance, like the tables that you have, the floor, the walls, right? Light rays are still reflected off the wall, the table, the floor, the sofa, the chair, the ceiling, so on and so forth. Now, although this surface might look like it's very smooth, but they are actually rough if you look at it at a very microscopic level. And because the surface is rough, it results in a lot of uneven terrain. So when the light rays hits, let's say this spot, right, the normal is actually represented by this normal line, but for the other light ray, the normal is actually represented by this normal line, because remember the normal must be perpendicular to the surface. So likewise and like over here. As a result, all the angle of reflection will be different because all the angle of incidence will be different. So you can see that some of the angle of incidence is quite small, like this one over here, whereas the other angle of incidence is slightly bigger. As a result, if the object is over here, with the light rays that's coming towards the surface, when it's reflected off, the object that you get over here, right, will not be as what it is, because it will be a very blurred image, it will be very distorted, right? It can be or it can be that you can't even see at all. For instance, the wall or the table, you can't see your own reflection when you stand in front of the wall, right? So this is an example of what we call diffuse reflection. Right? Diffuse because the image is blurred or it's non-existent. So these are the first four concepts that you learn in the ray model of light.